Hey, hello everybody. So today we're doing 7.3, multiplying polynomials. So we've done adding and subtracting. We've also done, what is a monomial, what is a polynomial. So now it's time to move into multiplying them and how we deal with that type of situation. And the word that we're going to be using a lot in here is distribute and the distributive property. So hopefully everyone can remember that from way earlier in the year. So if you have some particular number, like say a 2, that's going to distribute to 3x minus 5, we now know that we can call 3x minus 5 a polynomial made up of two different monomials. And when I distribute that, the 2 is going to multiply the 3x, and the 2 is also going to multiply the negative 5. So that's going to equate to 6x minus 10. And we want to do that exact same thing on these example problems that we're going to do right now. Zoom in a little bit. So our first question is, what happens when I'm not just distributing one number, but I'm distributing a whole other binomial? Right? This is a binomial made up of two monomials multiplying a binomial made up of two monomials. What happens when it's not just 2 that's distributing, but it's also x, so x plus 2 that's distributing? Well, really nothing changes. All right? And I want to emphasize that as much as possible. Nothing changes. The 2 is still going to get distributed to x. The 2 is still going to get distributed to the 5. So when I distribute 2 to x and 2 to 5, I get 2x plus 10. But there's a little bit extra. I have to distribute the x to both things too. X goes to x, and x goes to 5. X times x is x squared, and x times 5 is 5x. Now, all I have to do is combine like terms, put it in the proper order, descending order. So x squared goes first. I have 2x and 5x. That's going to combine to 7x. And also a plus 10. All right? So all I did was just distribute with one number and distribute with the other one. Now, how did I know what all of these signs were going to be? How did I know that it was plus 10 plus x squared plus 5x? Well, it all depends on the sign of the numbers that are multiplying. Right? And it's going to change in part B, because in part A all we had was positive numbers, so it was nice and easy, everything came out positive. In part B we'll see it's a little bit different. So let's look at part B. Same type of situation. I have to distribute the x to both terms, which will get me x times x is x squared, and x times negative 4. X times negative 4. Keep in mind that the sign in front of the number goes with that number. So x times negative 4, negative 4x. That's how I can get a negative. And then I have to distribute the 3 to both. 3 to x and 3 to negative 4. So 3 to x, remember it's a positive 3 to a positive x. So that's plus 3x. And then a positive 3 to a negative 4 gets me minus 12. And now all I have to do, combine like terms, make sure it's in the proper order. Descending means x squared goes first. Negative 4x combined with a positive 3. That leaves me negative 1x and minus 12 at the end. Okay? Now, there's a couple of little hints or tricks or little things to help you remember how to do this or help you do it a little bit easier. One of those ways is called the box method, which pretty much means you're going to do exactly what it says, make a box. And along the box you will put your binomials. So up on the top I would have 2x and negative 3, signifying this binomial here. And then on the side I would have x and positive 5, signifying this binomial over here. Alright, so now on the inside, what I'm going to do is multiply as if I'm doing kind of like a rows and columns multiplication table type thing. I will multiply x and 2x, which will get me 2x squared. Here in this box will be x times negative 3, which gets me negative 3x. Here in this box would be where 5 and 2x meet, so that would be 10x. And over here in this box would be where 5 and negative 3 meet, negative 15. Then I can take all of these products, and all I have to do is combine them and put them in the right order. Descending order means 2x squared goes first. I have quite neatly, in fact, like terms upon the diagonal, and that will happen every time. Negative 3x and positive 10x gets me plus 7x, and then negative 15. So that's like a nice, neat way to keep things in order. And let's do it one more time just to make sure we've got it fully. We make our box. And we put r and minus 5 along the top. We put 2r and negative 1 along the side. And then all we have to do is fill in the box. So r times 2r gets me 2r squared. R times negative 1 is negative r. 2r times negative 5 is negative 10r. And negative 1 and negative 5 makes positive 5. Now I realize along the diagonal are my like terms. And I just combine and write in descending order. 2r squared, negative 10r and negative r makes negative 11r, and positive 5. Okay, so that's one trick. And one nice kind of simplified way if you don't like to think of distributing one number and then distributing the second number. Another way, and this relates more to the distribution part, to remember to make sure that you distribute every single number and make sure you get them all, is a little mnemonic here called FOIL, and you might hear people use that a lot. It stands for first, outer, inner, and last. So it's a little way to remember and make sure that you're distributing and multiplying every number you need to, and it only works with binomials, okay? Only with binomials. FOIL does not work in the next example we're going to go to, where you're doing a binomial times a trinomial, or a trinomial times a trinomial. Okay? It only works when there's two terms multiplying two terms. But you want to make sure you multiply the first terms, you want to make sure you multiply the outer terms, the inner terms, and then the last terms. Okay? I would prefer that you try and remember this as distribution, just distributing to both with one term and distributing to both with the second term, because that's a more constant idea. That idea will be true whether it's binomials, trinomials, or much larger polynomials. But if FOIL is a nice way for you to remember for binomials, then by all means grab onto that. Okay, so now here in example 3, I want you to do A and B, and I know it says multiply using FOIL, but I'd rather you just multiply both of these binomials however way that you'd like to, given that you could do distribution, or you can do box, or you can use FOIL. Okay? Choose whichever way you'd like to. I'm very curious. I'd love to see what you do when I check it over in class. What I want to do is move on to example 4, which is what I was talking about before, how the FOIL method won't help you when you multiply a binomial and a trinomial. Okay? It doesn't quite work because if you do first, outer, inner, last, you're still missing two pieces of multiplication that should be in there. So, repeated distribution is a nice, easy way to make sure you're getting everything. Distribute the x to every single term. Distribute the 5 to all three of the terms. or the box method. So let's do repeated distribution first. I'm going to use blue for the top. I do x to x squared, x to negative 3x, and x to negative 2. Makes nice little rainbows. And what do I get? Actually, I'll keep it in blue. X to x squared gets x cubed. X to negative 3x gets negative 3x squared. X to negative 2 gets negative 2x. Be very, very certain that you are keeping and paying attention to the signs, because that will mess you up. 5 goes to x squared, 5 goes to negative 3x, and 5 goes to negative 2. And what do I get? Well, 5 to x squared gets me plus 5x squared. 5 to negative 3x gets me negative 15x. And 5 to negative 2 gets me negative 10. Put them all together. Let's see, what kind of like terms do I have here? I have x cubed, that's all by itself. I have, cross it off so I don't get confused. I have negative 3x squared and positive 5x squared. So together that makes plus 2x squared. And those are gone. Now I have negative 2x and negative 15x. Together that makes negative 17x. And those are gone. And negative 10 all by itself, tacked on at the end. Okay, now using the box method, I could do the exact same thing. I am going to need a bigger box though. All right, it gets a little more like a rectangle because I need to have 3 terms along the top. I need to have x squared. I need to have negative 3x. I need to have negative 2 to represent the trinomial. And also on the side, I need to have x and 5. So now, when I go about doing my multiplication, I should get the same numbers. I get x cubed here. Over here, I get negative 3x squared. And I get negative 2x. And down here, I get 5x squared. I get negative 15x. And I get negative 10. Just like in the ones before, my like terms are right here on the diagonals. So that's nice and easy to keep organized. And then I could rewrite the whole thing. Now I'm not going to bother rewriting the whole thing because I know it's just going to come out to be the same thing as this. Okay? So repeated distribution or box method is what's going to work for these much larger situations, trinomials or larger polynomials. Now, example 5. In example 5, we are looking for, once you get past the idea this is, a hockey rink, and we're looking at a specific area of that hockey rink. It's essentially just, this trapezoid right here, where the top is x, the bottom is x plus 10, and the height is x minus 7. So once we, get past all of the fluff of the problem, we start looking at just, the mathematical part of it, we want to write an equation that represents the area. And right off the bat, you might be like, I have no idea what the area of a trapezoid is. Well, the area of a trapezoid, for those of you who are thinking that, is 1/2 the height of the trapezoid times one of the bases plus the other base. And what I mean by that is this is considered a base, the x up here, and this is considered a base, the base on the bottom. All right? So it would be the sum of those two times the height times 1/2. So what does that look like? It looks like 1/2 times the height, which is x minus 7, times b1 plus b2, that's going to be x plus 10. And that's going to get multiplied. 1/2 times the height times the two bases added together. Okay, so now it looks like we have polynomial addition and we have polynomial multiplication going on here. 1/2 x minus 7 And then when I do the addition here, I take away the parentheses, remember, and then I just combine like terms. 2x plus 10. Not too bad. Now it's just a matter of binomial multiplication and distribution. I am going to leave the rest of this for you. Okay, we will see where you get by next class. Hopefully, you can finish this quite simply, and it's not an issue. But you're going to be multiplying two binomials, distributing a 1/2, and then in part B, you're going to find the area of the region when the shorter base is 18. Okay, so the shorter base is this one up here. Think about what that implies. If the shorter base equals 18, what does that mean for the variable in the equation? Try it out, and we will talk about it next time.